Today we are going to conduct an experiment called as a pressure gauge. What is pressure? Pressure is nothing but force acting on unit area. Whenever force acting on unit area, you will get some pressure in a system. So to find the pressure in a system, it is very important. Example in steam pipeline or boiler or any hydraulic pipeline or pneumatic or hydraulic systems, pressure gauge plays a major role here. Here we are going to calibrate a bottom tube pressure gauge with respect to the dead weights, and we will find the error in the systems to know whether your bottom tube pressure gauge is correct or not. Okay, how to do that? I have a piston cylinder arrangement here. Here I have a cylinder which is filled with a hydraulic oil, and I have a piston arrangement. Whenever the piston is compress the oil in the cylinder, it will build a pressure in the oil that will be lifted through a dead weights. So this is the load acting on your unit area is your plunger, that is the diameter, small diameter 5 mm plunger. So force acting on unit area gives you the pressure. That will directly build it through the bottom tube pressure gauge. You can see in your theory the bottom tube pressure gauge will be explained properly, how it will be works and how it will be going to work. The working principle you can see through any book. So here I am going to tell you how to conduct the experiment. Here we have a dead weights in the form of ATA, nothing but atmospheric temperature altitude. That is nothing but 1 kg, 1 ATA is equal to 1 kg per centimeter square. The pressure unit. Here we have a bottom tube pressure gauge. Here we have a dead weight. So I am going to log the release valve. There is one more valve called as a release valve. Whenever the excess pressure is given, the excess oil will be flow through the release valve, and it will not going to affect your system. I just log the release valve here. This is the release valve. If I log this release valve, it will be locked. And if you give a pressure, you can see this. There is a 1 ATA already mentioned here. 1 ATA is nothing but 1 kg per centimeter square. So whenever the pressure is built in a system, you can see this. Whenever the pressure is built up to the 1 ATA in a cylinder, it's going to lift your plunger. 5 mm diameter, that is pi d square by 4. So that will give you the area. 1 ATA divided by pi d square by 4, that is 5 mm. That you can convert as a centimeter. You will get some 1 ATA is nothing but 1 kg per centimeter square here. So you can see here. So it's going to lift it. So it has been given reading on a bottom tube pressure gauge. It's given, you can see what is the least count of the system. So 1 kg per centimeter square is divided by 1, 2, 3, 4, 5 divisions. It means 0.2 kg per centimeter square is the exact reading of each reading. It means it's giving 0.8 kg per centimeter square, but actually in a system it has been built at 1 kg per centimeter square. You can apply the next. I am just loading one more ATA to show you how it will work. I'm just releasing the valve. I'm just loading another 1 ATA here. I'm just locking the releasing valve here. If you give a pressure, if you build a pressure on here, you can see this. It's gradually increasing the reading in the bottom tube pressure gauge, and whenever the weight is lifted, the pressure built in your system is equal to the load acting on your system. So you can see this. It's giving 1.8 kg per centimeter square, but actually we loaded 2 kg per centimeter square. That is the error in your bottom tube pressure gauge. So if you want to know what is the error, you should plot a graph. Why we are plotting a graph means graphical representation will give more effective while you are doing the inspection. That's why we are going to use a graph to represent your bottom tube pressure gauge here. So how to write the load versus your error. If you write actual reading versus error, it means 2 ATA is your x means what is the error in your system. If you write x versus y, if you plot a graph, you will know how the bottom tube will behave with respect to your load. Thank you.